I'm Becca, and we're from the Chemical Engineering Project section. This is our presentation for our proposed structure for the Common Project. The purpose of the project is to design a building fully powered by solar energy. It will use the space outside of Pupin efficiently and create a new area for students to gather. We chose a hexagonal shape for our building to make it interesting, unique, and aesthetically pleasing. 3 of the walls will be open, so the structure will be have plenty of fresh air and feel as if it's part of the outside. However, in the case of inclement weather, these walls can be covered up so the inside of the building is fully enclosed. The height of the building is about 3.1 meters tall, and each side length is 10.06 meters.
Hi, my name is Kristen, and I'm going to talk more about the design of the building in detail. As you can see, inside of the structure, we're going to have 2 vending machines, a coffee station with K-Cup dispenser, 2 TVs to show campus updates. We're going to have indoor fountain, 6 outlets, and 8 light bulbs, and of course a lot of seatings and tables as well. We used program Google SketchUp to make a model of our structure. The building you see here is Pupin, so this is the view from southwest going into the building. So, as Becca mentioned earlier, we have 3 openings. This is going into Pupin's building. We have indoor fountain in the middle of the structure, TVs on the wall, and then 2 vending machines as well here. The coffee station is on the other side of the wall, and there's a K-Cup dispenser. You can't really see because there are a lot of people standing in front of it. And there are plenty of seatings and tables for people to just come hang out and work.
I'm Sam, and I'm presenting how much energy we will require in our structure, and this is a chart of our data. First, we have 2 vending machines. Collectively, they take 625 watts of power, and they will be running for the full 24 hours. So when converted into kilowatt hours, we get 15. Then we have 8 LED light bulbs, which collectively take 68 watts. They'll be running for as long as the building is open, which is 16 hours. So per day, they will consume around 1.1 kilowatts. Then we have 6 outlets, which we will use to power things such as the K-Cup, the water fixture, the solar server, and the vending machine. Collectively, they take 270 watts. They will be on for as long as those items are on, which is the 16 hours. So they take 4.32 kilowatts. We have our Keurig K-Cup, which takes 360 watts. It will be on for as long as the building is open. So it takes 5.7 kilowatts. We have 2 TVs, which have a power rating of 4 watts. They'll be on for as long as the building is on, which is 16 hours. So they consume 0.06 kilowatts. We have a water fixture, which consumes 16 watts for the pump. It'll be on as long as the building is open, the 16 hours, and it takes 0.25 kilowatts. Lastly, we have our solar server, which will be powered by 84 Raspberry Pis hooked in parallel, which will host our website. Collectively, they take 300 watts of energy, and they must run for the full 24 hours. So per day, they consume 7.2 kilowatts. Total, our structure will draw 34 kilowatt hours per day.
My name is Victoria, and I will be talking about the calculations. So we need 1,054 kilowatt hours per month, and on the roof structure we can fit a maximum of 322 solar panels. First calculated the amount of energy we get assuming no shading, taking into account the intensity of the sun in winter and the maximum area of solar panels. Then, using the Google SketchUp model, we calculated the sunlight on the roof in winter, and then by using an intensity and time of day graph, we calculated the total power obtained from the sunlight on the roof structure, factoring in shading. However, the solar panels produce DC current, and most of our amenities run on AC current. Therefore, we used the direct factor of 0.77 to factor in this power loss. In total, we get a maximum amount of 5,100 kilowatt hours per month. Based on these calculations, therefore, we need 241 panels out of the 322. We can have it a maximum.
I'm David, and I'm here to wrap things up and suggest a few other options for the solar panels. First of all, we considered, although we didn't have the time to do the calculations, that you could put these solar panels perhaps on the northwest corner building, on Carmen, or on Mud, basically to minimize shading. You get more energy and would require more panels. And this project will help Columbia to become a role model in environmental technology and environmental awareness, while also providing an aesthetically pleasing and very nice hangout spot for students and faculty members. Pick us, woo.